Today we're going to look at 2.4, which is on solving linear inequalities. So remember, if something is an inequality, you will see one of those four symbols in place of an equal sign. Less than or equal to, greater than or equal to.
Look, we keep coming back to these after we stop talking about it.
Yeah, well, we haven't talked about how to solve them yet. I think most people remember from Algebra 1. But we haven't talked about, like, if you multiply or divide both sides by a negative, you're supposed to do something. Which, again, hopefully you remember.
Yes.
So, those are examples of inequalities. The one on the left is a true statement. The one on the right is something that would need to be solved to figure it out. And we solve it very similar to how we solve an equation. So if I wanted to know if a particular number was a solution, we figure that out very similar to an equation. We take that number, plug it in, and see if you get a true statement. The difference with an inequality is there's usually, or there can be, an infinite amount of answers. Versus an equation, it can have an infinite amount of answers, but that's more of a special case. Having an infinite amount of answers with an inequality, that's pretty normal. That happens all the time. So if I wanted to know, for example, in this inequality, if 5 was a solution, I would fill it in for x. Is 3 times 5 greater than 12? Yeah, then 5 is a solution. How about 4? 3 times 4 is greater than 12. No, 12 is not greater than 12. So that's all you have to do to check if if a number is a solution. And in this case, the answer is anything that is greater than 4. That would be the answer. So when you have a conjunction, that's two inequalities connected with the word and. Does anybody remember how you can combine two separate inequalities that are conjunctions into one? I'll give you a hint. You usually start with the x in the middle, and there's two ways to do it. Yeah?
What I do is I put the x in the middle, and then I do the one where, like, the small side on the left, less than, right?
Yeah.
I do one on each side. And then I do the smaller number on the left, so -1, and then the bigger number on the right.
Perfect.
Yeah.
So that's one way you can do it. Can anybody tell me the other way you could do it?
The other way, I guess.
So what would be another way you could write that? And it would still be correct. Yeah?
You just flip the signs so they're greater than, and then you put the small number on the right instead of the left. And bigger, yeah.
Means the same thing. Here you've got x is greater than -1. Here you've got x is greater than -1. Here you've got x is less than 3. And here, x is less than 3. So what this kind of statement usually means is it's a range of numbers. Another way to say it is between. We're talking about all numbers between 1 and -3. So we've talked a lot about intervals, and that's an example of an interval. This is called an open interval. We'll talk more about that in another section, but it's an open interval because it means you cannot include either end of the interval. Not -1, not +3. Yeah.
Why is this called a range instead of a domain?
I think here they're not really using, like, the technical word domain and range. I think they're using the word range, like if I said to you the range of scores on the last test was between 70 and 90. So there was like a 20-point range in scores. So they're not, using it in like a technical word. I can see where that could be confusing. So again, this is called an open interval.
Do you know why yet?
What's that?
Why is it an open?
It's an open interval because open means do not include the endpoints. So we're going to talk more about intervals right now. We're going to use a couple words to describe it. Open versus closed, and bounded versus unbounded. So with an interval, you really can have 4 types of bounded intervals. If an interval is bounded, that means its left and right ends are actual numbers. The minimum of the interval is a number value, and the maximum of the interval is a number value. If you're thinking, well, what would it have to be unbounded? Well, think about something you could have that's not a number, and we've used this symbol before. We'll talk about that next. Okay, but bounded intervals use numbers. If an interval is bounded, there are 4 different types. First of all, you can have what's called a closed interval. Closed means, for example, if I said pick any number on the closed interval from 1 to 10, you could pick any number from 1 to 10, including 1 and including 10. Now, if I said pick any number on the open interval from 1 to 10, that means you can pick any number between 1 and 10, but you cannot pick 1, and you cannot pick 10. So closed means include it. Open means don't include it. What else do you think we can have besides closed and open? Yeah. We can have a half open interval. This one is specifically half open on the right, and that one is half open on the left. So in the top one, in this one, you can include A, but you cannot include B in your interval. And in the bottom one, you cannot include A, but you can include B. If you want to think about what these look like as graphs, it looks something like this. A, B, open circle, shade between. Half open, okay, so make another number line. A, B, filled in circle on A, open circle on B, shade between. And you can, look at the other types on page 99 if you want to see. So these are bounded. The other type of interval we can have is unbounded. What do you think you would see in an interval if it is unbounded? Yeah? You would see infinity. So an unbounded interval can use either a positive or negative infinity. Is it possible to have an unbounded closed interval?
No.
No. Because unbounded means it has infinity. If you have infinity, you automatically have to put a parenthesis on it, which means it's open. So you cannot have an unbounded closed interval. You can have an unbounded half closed or half open. You can have an unbounded fully open, but it can't be closed. And if you want to see pictures of what these would look like this one, this says any number greater than or equal to 5. So essentially that looks like this. These are the type of intervals where you end up shading in one direction as a red. It's not a shade between when it's unbounded. And this one down here would be like this. Any questions on that? Okay, so now we should be able to translate between inequality notation and interval notation. This is an interval, but can somebody translate that to a conjunction for me? John?
So you do -3 is less than x, which is greater or less than to 5.
Perfect. Interval notation, inequality notation. And then you could also do graphic notation where you put open circle, closed circle, and shade on a number line.
Alright, so it's going to be that easy. How looks like you just plot the numbers twice.
Yeah, it's
But
translating between inequalities and interval notation is pretty straightforward.
you just put x in the middle and make sure that the signs are right.
Put the proper signs, yeah.
Yeah, interesting.
How about this one? The unbounded half open interval from -4 to infinity. Yeah?
-4 is less than or equal to x, which is less than infinity.
Okay. So you could do that. Can anyone simplify that for me? Yeah?
-4 is greater than or less than or equal to x.
Yeah, really, you could just say that x is any number greater than or equal to -4. I know that x is less than infinity. Everything's less than infinity. So you don't really have to say this part, but you do have to say this part, which I wrote with the variable on the left. But any question on that? Okay. How about this one? First of all, what kind of interval is it? Is it open or closed? It's fully closed. Bounded or unbounded? Bounded. Now, if you said fully closed, does that automatically mean it's bounded?
Yes.
Yes.
You can't close in on it.
Right. You can't close an unbounded interval. So, all right. How would we write C as an inequality? Nate?
-8 is less than or equal to x, which is less than or equal to x.
Yep. Inequality notation, interval notation. Questions on it? All right, now let's do the other notation, which is graphic. We've already spent a little bit of time on this, so can someone remind me quickly when you make a number line, what is one symbol that I could put on the two? I could use what? Yep.
You could use a closed circle.
Could use a closed circle, or if you think about it in terms of interval notation, that is a symbol you could pick from, but it's not the right one for a greater than or equal to.
Oh, no, that's a bracket.
It's a bracket. So you either could do this and shade right, or this and shade right.
Oh, that's great.
They're both correct. How about x is less than 5? What kind of symbol would I put on the 5? Yeah? Open or parenthesis. There's your open circle. And you're shading everything smaller than 5. Okay, conjunction. All right, what kind of symbol could I use on -1? Yep.
Could do a closed circle on -1.
Okay, if we decide to start using circles when we graph it, we're going to stick with circles for the whole problem. So now brackets and parentheses are not something you could use. So we get a closed circle. What else?
You could do open circle on 3 and then shade between.
And shade between. Or bracket on -1, parenthesis on 3, shade between. So that's borrowing the symbols from the interval notation.
Keep that up there for a second.
Any questions on that? So, when we want to solve inequalities, it's pretty much the same steps as when you solve a linear equation. I kind of hinted at it earlier, but what's the one thing that you got to be careful about when you're solving an inequality? If you do what? Yeah?
Dividing by a negative number.
Dividing by a negative, or
Square root of negative number. Oh, no, sorry. Never mind.
multiplying. Dividing, multiplying, kind of the same thing. So if you multiply or divide by a negative, what ends up happening? What do you got to remember?
The sign flips, right?
The sign flips. So if you multiply or divide each side of an inequality by a negative, you need to flip the sign. If it was greater than, it becomes less than. If you forget to flip the sign, then you could end up shading completely the wrong way, which would be wrong. So let's look at this one. So it says 3 times x plus 1 plus 2 is less than or equal to 5x plus 6. Okay. What would be my first step? About max. What's my first step here if I solve this one?
Simplify.
Okay, and what would you do to simplify?
Wouldn't you times 3 by x and 3 by negative 1?
Yep, exactly. And what do you get when you distribute that out?
3x minus 3.
So we're going to have 3x minus 3, but we can combine the minus 3 with a plus 2.
Minus 1.
So let's just do minus 1 all in one step. Less than or equal to 5x plus 6. Okay, JC, what could I do next?
You can switch this up. So you're gonna want to subtract 3x from both sides.
Okay, so I'll do 3x. And at the same time, what else could I do?
You can subtract 6 from both sides.
Okay, take care of that. Negative 1 minus 6 is negative 7. 5x minus 3x is 2x, and now she subtracted on both sides. So do I flip the sign?
No.
No, that's subtraction. You never flip it with subtraction. And divide by 2. So we get, if you want to write this with the variable on the left, x is greater than or equal to negative 7 halves. Now here, this rewriting step that I did had nothing to do with dividing by a negative. I just wanted to rewrite it with the variable on the left. Questions on that? Questions on how you would translate that to an interval? It would be an unbounded interval from negative 7 halves to infinity. Closed on negative 7 halves. So, solving an inequality with a graphing calculator. There's really 2 ways we can do it. And this is helpful when we start to get into inequalities that might not be linear. Like something with like a cube root, something to a 3rd power or a 5th power. That starts getting more complex. So one way is kind of like you're solving a quadratic. Get everything on one side, and then calculate the root. For example, if you were solving 3 is less than 2x. Let's do it like this. Something like that. If you wanted to solve that linear inequality, yeah, you could just add 7, divide by 2, and be done. That'd probably be the quickest way. But if you wanted to graph it, you could get everything on one side. 0 is less than 2x minus 11. Then you would draw that. When you draw it, it's going to have a y-intercept of negative 11 and a slope of 2. So it's going to look something like that. You want to know where your inequality is below 0. This is the section that is below 0. The section I just shaded in black. So you would want to write down every answer from this point, and the x values can get smaller. If you pick an x value bigger than this point, then your y value is going to be positive. You don't want to be up here. You want to be down here.
Wait.
Yeah.
Alright, so how would you write that in the calculator? Do they have inequalities on there?
So what we're going to do is,
you would just graph it and then
we're just going to graph it like it's a line.
okay, yeah, that's right.
Then we're going to calculate the root. And from there, your answer is either everything below the root, or you want to know everything above the root. If it's a less than 0, you want the answers from here down. If it's greater than 0, in this case, would be from here up. So once you calculate the root, you're going to determine where it's positive or negative. Now, if I were to solve this one, I already know the answer. X is less than 3/4. Is there any question on that? Not a complicated one, not one I would really want to graph, but it's pretty basic, so it's a good one to do for the first time. If I wanted to get 0 on one side, what could I do here? Yeah.
Subtract 2.
Yeah. 4x minus 3 is less than 0. Now graph. So we're going to go to y equals. We're going to put 4x minus 3. And we are interested in where this particular graph is under the number 0. Where is it under the x-axis? So let's do zoom 6. Look at our graph. And we want our graph to always have a negative result. Less than 0. That's going to be from here down. So that means you could pick any x values to the left of where I circled. If you pick them to the right, it won't work. So, yeah. So you need to find that 0 value. Does anybody remember how you calculate 0? Yeah?
Second count.
Yep. 0. Pick a point to the left, to the right, okay, and then it'll look like that. And now, guess, just hit enter, and it tells you that the root is 0.75. So 0.75 is the boundary between positives and negatives. If you plug in values bigger than 0.75, you'll get a result greater than 0. If you plug in less than 0.75, you'll get a result less than 0. Yeah?
Could second count 0 find the y-intercept?
Um,
Or is it only for the x?
No, it only finds the x-intercept. Yeah, no way to find the y with the calculator. So the answer here is all x values less than 0.75. So that's one way to solve an inequality. Get 0 on one side. Second way, leave it the way it is. Don't get 0 on one side. Take your inequality the way it is. Put the left side in y1. Put the right side in y2. Just like that. Now, I'm looking for where the 4x minus 1 is under the number 2. So in other words, I'm looking for where the blue graph is under the red graph.
Right, is this the second method here?
Yep. Method 2. So I'm going to hit graph. And what do you think I'm going to calculate this time? I'm going to calculate the intercept. I want to know where, if I just color code it the way my graph is, that's the blue one, that's the red one. I want to know where the blue graph is under the red graph. That's from any value here to the left. X values to the left of that point will put my blue graph under the red. If you pick an X value to the right of that point, your blue graph is going to be up above the red. So we do second calc intersect. And I get an intersection point of 0.75. Now we just decide, do we want things less than 0.75 or more? Well, we want the blue graph under the red graph. That will happen as the X values go to the left. So we want everything less than 0.75.
And that would be the same if you change it to first.
So it's exactly the same answer. It's just a different way of doing it. A root versus an intercept. Any questions on that? In general, if it doesn't say which method to use, I don't care which method you use. Okay? You can do it as a root or do it as an intercept. All right, is that the one I just did? Yeah, so I just did number 5 as an intersect. It was the same as the last example. So I'm not going to do this again. All right, double inequality. So to solve a double inequality, you want to get the variable alone in the middle, if you can. If you can't, what you can do is take this original problem and split it back into 2. Sometimes that's how you have to do it. So this would be like -8 is less than 2x, and 2x is less than 12. If you can't get the x alone in the middle easily, and in this one you could, all you'd have to do is divide everything by 2, and you'd be done. But if you can't, split it back into its original 2 problems, and then solve each one separately. So you might be thinking, well, how could you have a problem where you can't easily get x alone? If you start getting x's in more than one spot, like -8x is less than 2x plus 3, which is less than 12. Well, the problem with that is you could say, all right, I want a -3 from everything, and then say, all right, well, then I'll divide everything by 2. But you're still going to end up with x's in these 2 spots. And then if you say, well, all right, I'll just try to combine all the x's together. Well, I mean, what are you going to do? Add 8x, and then add 8x. So now all you've done is move the problem to the other side. So when you have something like that, you're going to have to split it into -8x is less than 2x plus 3. Solve that. And then 2x plus 3 is less than 12. Solve that separately. All right, but we're going to try one where we can get the x isolated in the middle. That's the easier one. Just remember, whatever you do to the middle, you have to do on the left and on the right. Okay, when I look at that quick, I know that I can isolate the x in the middle, that this is the easier one, because I don't see x's outside the middle in the other spots. I only have a single x in the middle, so that's good. And does anyone think they would see the first step to start to get at least this part by itself? Yeah.
Times 3.
Yeah, I'm going to times 3. Times 3, times 3, times 3. That's good. And when I do that, Ian, can you tell me what I have?
Negative 9 is less than 2x plus 5, which is less than or equal to 15.
Right. Same rules apply. If you multiplied by like a negative 3, you would flip both sides. But we didn't multiply by a negative, so we're good. What's my next step? Yep. Subtract 5, 5, and 5. And can you tell me what I get when I do that?
Negative 14 is less than 2x, which is less than or equal to 10.
Good. And what about my last step? Yeah.
Divide by 2.
Divide by 2. Divide by 2, 2, and 2. And Eric, can you tell me what I get?
Negative 7 is less than x, which is less than 5, or less than or equal to 5.
Yeah. Less than or equal to 5. There you go. Pretty straightforward because the x was in the middle and we could isolate it. If you can't, do what I suggested earlier. Split it into 2 problems. And then you'll be fine. Okay, questions on that?
Alright, and that the sign shouldn't have flipped at all.
No, because we multiplied by positive 3. And then we divided by a positive 2, so we never multiplied by a negative. This is kind of like the one we did in the homework, but we can look at it. So it says it's about a rectangle. Just another variation on a rectangle problem. It says, think about all the rectangles where the length is 1 more than twice the width. How would you write that? Length is, so I just did this part for you, 1 more than twice width. Yep.
It'd be like 2w plus 1.
Yep. Good. 2w plus 1. I don't know if we're going to need that, but I'm guessing they told us it, so we will at some point. It says, find an algebraic representation of the rectangles with a perimeter of 100. So perimeter is, what's the formula for perimeter of a rectangle? So 2L plus 2W. And they want a representation where the perimeter is less than 100. So we got, okay, so fill in 100 for the perimeter. And now 2L plus 2W. Well, I'm going to put 2, but I'm not going to put L. I'm going to put 2W plus 1. Plus 2W. So there's an algebraic representation of all the perimeters that are less than, and it meets the condition that they set. The length is 1 more than twice the width. I guess at this step, if you left it as 2L, no, you need to substitute that in at this step. And now, solve it. Find all the possible widths of the rectangles. So 100 is going to be less than 4W plus 2W, which is 6W, plus 2. So 100, actually let's do 98, is less than 6W. So that doesn't go in evenly, which is possible. But the width has to be less than 16 1/3. So the width has to be, oh, no, sorry, greater than 16 1/3. If it's not, then you won't get a perimeter. I thought it should be less than. Perimeter.
That seems right.
I think it should be the other way, though. I think it should be the perimeter is less than 16 1/3.
Yeah.
Find an algebraic representation of the rectangles with a perimeter of less than 100. So you want perimeter less than 100. This is the formula. Yeah, that's the formula for the perimeter. So, yeah, we have the right formula, but I had the inequality flipped. I have, right now, I'm saying the perimeter is greater than 100. I don't want the perimeter greater than 100. I want the perimeter less than 100. So, everything we did was right, but this should be flipped. So it should be pointing to the right. And right. And this one, that makes more sense. Because they're essentially giving me a maximum. They want the perimeters less than 100. So that means the width would have to be less than 16 1/3. But what else would the width have to be? Definitely has to be less than 16 1/3, but this is like a common sense thing, yeah?
Greater than 0.
It still has to be greater than 0. So because we're talking about a measurement, technically you need to put this as well. Wouldn't make sense for the width to be -5. Okay. So that whole thing is your answer.
Oh, sorry. I said just zeros.
Yeah. All right, so absolute value inequality. Very similar to absolute value equation. We take our problem and we split it into 2. So you have to make sure it's isolated, which the problems that I give you, they mostly are. So make sure the absolute value is by itself. Split it into 2 problems. So here's what you're looking for. Something like that. Your first absolute value is just like we did yesterday. Take out the bars. X plus 3 is less than or equal to 5.
Can I guess the other one?
Sure.
Is the other one going to be x plus 3 is greater than or equal to 5? Or -5?
-5. Yep.
Yeah.
So yeah,
That's
second.
the sign, right?
Yep.
That's just like
Yep. So the second one, we got to do 2 things. Flip that sign and make that number the opposite of what it is now. So there's your first one. And there's your second one. Take out the bars. You have to do that all the time. Flip the sign and change the number from positive to negative or negative to positive. Now, there's one more thing that we have to write down, and it's a word between our 2 answers. When you write an answer to an inequality, it's either something and something, or something or something. We have to pick the right word, either and, or it could be or. The way you figure out which word you have is all based on this. You look at the original inequality. And if the original inequality, after you isolated the absolute value, has any kind of less than symbol in it, it's an and. Land. Less than is an and. If you had any type of greater than symbol in the original problem, it would be an or. So land and gore. I don't know if that helps you to remember, but that's how I remember it. Less than, even if you pronounce it that way, less than, let's say less than is an and. Greater is an or. And that's the same thing I wrote right here. Less thans use and, greators use ors. Greater, or. So let's try this one. Is the absolute value isolated already? Yes. So then we are ready to split it. What's going to be my first inequality when I split this up? Yep.
X minus 3 is less than 3.
Perfect. X minus 3 is less than 3. My second inequality? Yes.
X minus 3 is greater than negative 3.
Good. And should I put the word and or between them?
Would it be and?
This is an and. The original symbol here, after it was isolated, was an and. So, then solve it. So x is less than 6, and x is greater than 0. So that's all numbers between 6 and 0 as an open interval. Questions on that? So one thing they give you that is a little bit tricky with wording if you haven't seen it before is if I want to write something like, give me an absolute value that represents all numbers that are within 2 units of 5. So if you think about it on a number line, what I'm getting at, if you want to know something that's within 2 units from 5, that means you could go as high as 7 and as low as 3. Those are the numbers within 2 units of 5. So in general, what about if I said within A units from the number B? That's your formula. To write down an absolute value expression that represents all numbers that are less than A units from B. So A is how far away you can be from the value, and B is the value that you're starting. So B is like in the middle. A is how far you can go on each side of it.
And B is what?
So B is the middle. It's your starting point, and A is how far away you can go on each side of it. And this formula will give you the answer to a problem like that. So this is the part that's like in the middle. And then how far away from that value in the middle. So if I want it to be within 4 units of the origin, well, the origin is what value?
0.
0. So I basically want to be up to 4 units away from the origin. what's my b value in this case? What's the value that I'm going away from?
0.
Going away from 0. And how far away can I go up to from it?
4.
I can go up to 4 units away. So this would be the answer. If you pick a number and it has an absolute value of less than 4, then it will be within 4 units of the origin. How about x is less than 3 units from the number 2? In this case, what's the value that we are moving away from on each side? 2. And how many units can we go up to away from that number? 3. If you solve that inequality, it will tell you all numbers that are less than 3 units from the number 2. So it's just a formula that translates a sentence into an inequality. A little tricky if you haven't seen it. Now that you've seen it, you know the pattern, and that's what you use. Those are our last two. I'm going to skip this. We did an and problem right here. What would this one be? That's an or problem. Usually when you graph an and problem, it's a conjunction. You shade between. Where do you usually shade with an or problem?
In the middle or on the opposite.
Opposite ends. So an or problem ends up shading opposite. So let's look at this one. Solve algebraic. This will be our last one. They want to know where x plus 3 divided by x minus 2 is greater than 0. Yeah.
Multiplying x minus 2 on the other side.
So the only problem with multiplying by this is, if we multiply by a negative, what are we supposed to do?
Oh,
We're supposed to flip the sign, but the problem is we have an unknown here. We don't know what that x value is. So we don't know whether or not we should be flipping the sign.
so it's gonna be like if it's negative, flip the sign, and if it's not, don't or something like.
Oh, wait, isn't the 2 negative?
Well, think about, we want to know where it's greater than 0. So tell me one way that a fraction can come out greater than 0. If you had what kind of number in the top and what kind of number in the bottom?
The numerator greater than the denominator. What do you mean?
So in general, if you want to divide two things and get a result greater than 0,
Positive integers.
if they were what?
Both positive integers.
Or fractions, that's fine. But the point is, if you divided a positive by a positive, you would get a result greater than 0. What's another way? Yeah?
Both negative.
If you divided a negative by a negative, you would also get a result greater than 0. One of these situations is impossible in this problem. Yeah?
So you multiply it by -1. Is that what you would do?
So first, which situation here is impossible? The first one or the second one?
Second one.
Yeah, why is this impossible?
This absolute value can be negative.
You're never going to get a negative in the bottom. And if you can't get a negative in the bottom, then this situation could never happen. Could you get a positive in the bottom? Yeah, you could definitely get a positive. So the top is the only thing that really matters. All we have to do is make sure that the top comes out what? Positive. If you can guarantee me that the top comes out positive, then I guarantee you'll get an answer greater than 0. Because the bottom is already positive all the time. And you'd have a positive over a positive. So what kind of numbers would you have to pick for the numerator? Anything greater than -3, except what?
0. No, -2. 2.
2.
Not negative 2. Yeah, because it would make the denominator 0.
Right, that's another problem. We can't divide by 0. So we could pick any value that's bigger than negative 3 that will guarantee the top comes out positive, and we just can't pick 2 in the bottom. So this is anything greater than negative 3 except 2. How would you graph that? Like this. Anything greater than negative 3 except 2. So I put a hole at 2, so I don't include it. Any questions on that? Okay, so that's solving linear inequalities. We'll go over that tomorrow when we do the homework. So for tonight, it's just page 108. It might go on page 109 as well. It's about the same amount of questions you had last night. They're just spaced out. Because it's, yeah, I think last night you had, what, 19 questions?
I don't know, 24, right?
Was it 24? Well, I think that's...
5 in the first, 2 in the second.
So yeah, 19. Oh yeah, plus the 5. I think that's less than 24, so it might be less than last night. Yeah.
Is it even only for 34 and 38?
Yes. So we'll take a look at that first thing tomorrow.